Good. All right, so now we've got our augmented matrix. Remember, this is the X column, this is the Y column, this is the Z column, and these are the answers, right? And what we're going to do is we're going to do something called row operations. And remember, our goal is to have ones on the diagonal, zeros here, and doesn't really matter what we have here, just whatever we have here happens. Okay? The goal is ones here, zeros there.
This is like a puzzle.
In a way, yes. This is really the exact same thing as the elimination method for solving systems. We're just doing it in matrix form. And I think if you keep that in mind, you might see that as we do it. So here's how a row operation works. We can use row operations by combining multiplication and addition to make part of each matrix, to make each row have the same thing with opposite signs at some point to eliminate, to make one part of it a zero. For example, we've already got the 1 in row 1, right? It's right where we want it. Row 1 is done. I don't have to do anything to row 1, okay? But row 2 is not done. Even though I've got a 1 here, that doesn't matter until I have a 0 here, okay? So my goal is to make this 2 a 0. Yes?
Does the 3 and also the -1 have to be a 0 too? Because...
Yes, they will eventually, but we're going to work one row at a time.
Gotcha.
Yes.
So you just take from the first column and the second row, you take that -2 and you add to the 2 or something?
Well, here's the thing. You can only add like terms, right? So I can only add within a column. I can't cross add because this is a Y, this is an X. So they're not like terms. But I can multiply this by something, this whole row by something, so that when I add it to this row becomes a 0 right there. What would I have to multiply this by to make that happen?
0.
No, if I multiply this by 0, then all of them will be 0. That does me no good. 0 plus 2
I
is
thought you
still
were supposed
2.
to have.
Multiply this row by something so that when I add it to this row, I get 0 for the first part.
Okay.
What number is that?
-2.
-2, right? Because if I have -2 here, -2 plus 2 is 0. This is how you represent that idea for row operations. You put an arrow saying I'm going to the next step. Yes?
But isn't that going to change the 1 in the first row?
Well, theoretically, yes, but then we can divide it all by -2 again and just have it like this again. So we're going to not show it. Okay? What I mean by that is if I can divide it all by -2, or if I can multiply it all by -2, I could go back and divide it all by -2,
But
right?
wouldn't you have to divide the second row too?
No, you would not, because you only have to work with one row at a time. Remember, each row represents an individual equation, right? So, what I'm going to do is I'm going to do -2 times row 1. And I'm going to add that to row 2. And this is the tricky part of this, is that you don't show any of the work anywhere else. The work is implied right here, and then you just write the new matrix, creating a new row 2 because that's the thing that you want to change. Yes, Curtis.
So on like the quiz, it won't have the option to put beside word what you just wrote? Or will we?
The quiz is going to be partly multiple choice, but also partly work it out yourself.
So do we just put all the ones
You
diagonal and just zeros?
Well, just like this, let me get through the rest of this. I think it'll make more sense, okay? So, the next one, the first row is the way I want it. So I'm just gonna copy the first row. Because that's already done. The second row I want to change, and I want to change it using this right here. So, -2 plus 2 is 0. -2 times 2 is positive 4. 4 plus 1 is 5. -2 times 1 is -2. -2 plus -3 is -5. -2 times -1 is 2. 2 plus -7 is -5. All these 5s are coincidental. They really have nothing to do with each other. It just happens that the math works out, that the arithmetic works out that way. It's not that you're going to get positives and negatives of the same number all the time. That's not going to happen. -1 times -2 is positive 2.
Oh, you're just making
2
it.
plus -7 is -5.
Okay.
And the third row stays the same?
And the third row for right now stays the same because we're not changing anything on it yet. And then, so we've accomplished one goal. We put a 0 right there. That's a good goal to have. Yes?
Can you reiterate what you mean when you, above that arrow? I'm just not understanding.
Take everything in row 1,
Okay,
multiply it by
Oh,
-2, each
yeah.
thing by -2, and then take that answer and add it to row 2
okay,
to produce a new row 2.
I gotcha.
Okay. So we got a 0 here. What is our other goal with row 2? To have a 0 here and then here have a 1. How could you do that? With multiplication. Multiply 5 by what? 1/5. So my next row operation is going to be 1/5 times row 2 to produce a new row 2. My row 1 will stay the same. And actually my row 3 for right now will stay the same. And my row 2 will change.
I thought you just changed row
I'm just changing row 2. I did it before. I need to do it again to get 0, 1. 1/5 times 0 is 0. That's why we multiplied, by the way. So that stays a 0. And then 5 times 1/5 is 1. -5 times 1/5 is -1. -5 times 1/5 is -1. Row 2 is done. Right? Now, let's work on row 3. We'll come down here and work on row 3. I need a 0 here, a 0 here, and a 1 here. Let's get the 0 here first. Which row helps me get a 0 there? Row 1 or row 2?
0.
There. Should I use row 1 with row 3, or should I use row 2 with row 3? If I use row 2, will I ever be able to produce 0 here? How? What can I multiply row 2 by and then add it to row 3? Right, you can't, right? Because I'm going to be multiplying by 0, but I need -3, right? If I don't have -3, I can't add these and get 0. So I'm going to use row 1. Does that make sense?
Yeah.
Okay. So what do I multiply row 1 by?
-3.
-3. So that'll be -3 times row 1 plus row 3. Row 1 will stay the same. Row 2 is just like we want it, so it will stay the same. Now, -3 times 1 is -3. Plus 3 is 0. -3 times -2 is 6. 6 plus -1 is 5. I really kind of dislike that they made this so that there's 5s everywhere because it tricks people into thinking 5s are going to show up all the time, but they're not. -3 times -1 is 3. 3 plus 2 is 5. Did I mention I dislike that this always comes out to 5 in this particular example? -3 times -1.
You said
Wouldn't
you
the
were
last
using-
5 be a -5 because you're going on the top row? So -3 times 1.
Oh, wow, you're right. I was doing the wrong one. I'm so sorry. I apologize to all of you at home. -3 times 1 is -3. -3 plus 2 is -1. Good, at least we got something different.
Oh, I was wondering why you're using row 2.
Yeah, I shouldn't have been using row 2.
Okay.
Yeah.
Awesome.
-3 times -1 is +3. 3 plus 0 is 3. So I've accomplished one goal. Put a 0 right there. My next goal is to put a 0 right there. That will require using row 2. Because if I use row 1 again, I could do it, but I would not have a 0 here all of a sudden. And I want 0, 0, 1. So, since I have a 0 here already, I'm always going to produce 0 plus 0, right? So, I can make this, turn this into a 0 using row 2. So, what would I do to make that happen? Give me the language now. Read it off or tell me it like you would read it here. Something times row 2 plus row 3.
What are we changing?
We are changing this to a 0.
-5.
-5 times row 1, or row 2, plus row 3. -5 times row 2 plus row 3 will produce 0 right there. And that's all I care about. Whatever happens to the rest of the stuff just happens. First row stays the same. Second row stays the same. Third row still starts out with 0 because 0 plus 0 is 0. Then we've got -5 times 1 is -5 plus 5 is 0. And -5 times -1 is +5. 5 plus -1 is 4. And -5 times -1 is +5. 5 plus 3 is 8. And we have almost produced row echelon form. What's left?
Nothing, I don't want to do this anymore.
The 4 needs to be a 1.
The 4 needs to be a 1. How do you do that? Multiply by 1/4. So let's do 1/4 times row 3. The first 2 rows stay as they are because they're the way we want them. And the last row will become 0, 0. 1/4 times 4 is 1. That was the goal. And then 1/4 times 8 is 8 over 4. 8 divided by 4 is 2. This is row echelon form. And this tells us what z equals.
So what does it equal?
So What does z equal?
2.
2. And here's why. This is the x column, this is the y column, this is the z column. X is 0, so we can ignore it. We've eliminated it. Y is 0, we've eliminated it. Z times 1 is z. And its answer is 2. So z equals 2. That's why we did all that work.
It'll just always be the number in the last number. Right?
Yep. As long as you put it in the row echelon form.
It's easy for me to understand that the last number in, the bottom right corner would be the answer, but I don't understand how that's z though.
Because we designed it that way. We designed the augmented matrix that way.
Okay.
Everything in this column, in this first column,
Yeah.
was the coefficient of x in
Yeah.
each equation. This was the coefficient of y in each equation. This was the coefficient of z in each equation. And we just eliminated, we just separated the variables out from them because, and remember, this is all about computers here. Computers don't deal with variables. So you gotta toss them out. But you know they're there based on which column you're in. Okay? So this isn't just 1, it's 1x.
Yeah.
This isn't just 2, it's 2x. So when I got down here, this is 1x, 0x, 0x.
Mm-hmm.
Negative 2y, 1y, 0y. But 0 times x is 0, 0 times y is 0. And there is addition in between these. And then z and 1. That's 1 times z, which is z. This represents the equal sign,
Yeah.
and then 2.
Oh, we're,
Okay? Kathy?
so like the variable's it's not gonna be the number at the end, but how you set it up, it's gonna be the 1 times the variable equals that. But then when you get up
Yes.
to the next row, it's not gonna be,
Not quite,
it's gonna be,
but we're going to look at that.
okay.
So since z, go ahead. Okay. Since z equals 2, then if you move up to row 2, here's what you've got. You've got 1y, or y, right? Because 0x is just 0. 1y plus negative 1 times z equals negative 1. But we know z, so we can plug it in, thus giving us the ability to solve for y. Questions?
So you're saying that z times 1 equals 2, right?
Yes, essentially.
Okay, so is z always,
Z is always 2.
okay.
So what I'm going to use that fact to plug in here. Because now I can say y plus negative 1 times 2
Oh my god.
equals negative 1 because z is 2. Which then lets me say y plus negative 2 equals negative 1, add 2 to both sides, and y equals 1.
Is there a reason why we use the second row, or is it just that we can use the first and second?
The reason we're using the second row is because there's no x to deal with yet.
Oh.
Okay?
Yeah.
So we gotta move up one at a time because we gotta know the other variables before we can keep moving up.
Okay.
So now we know both z and y, so we can deal with row 1. So then, for row 1, we've got 1x, or just x, plus negative 2 times y, plus 1 times z equals negative 1. But we know all of these. This is x plus negative 2 times y is 1, plus 1 times z is 2 equals negative 1. So that is x plus negative 2 plus 2 equals negative 1. And it just so happens that in this one, and this will not happen all the time, this is a coincidence, That negative 2 plus 2 is 0, giving us that x equals negative 1. So now we've got all 3 values.
But x is equal to positive 1.
X is equal to what?
Positive 1.
No, positive 1 times x is x. Alana?
Question.
Yes.
So the original equation for row 1 said x minus 2y.
Mm-hmm.
Oh wait, that's why it's negative. Never mind.
Yep. That's why it's negative 2, yes.
How is it negative 1? I still don't get that.
Okay, let's look at the video.
How is what negative 1?
You just look the video later.
X.
Okay, so I did 1 times x is x, plus negative 2 times y,
And you
and y is 1, plus 1 times z, z is 2, equals negative 1. And then negative 2 times 1 is negative 2. 1 times 2 is 2. Negative 2 plus 2 is 0.
I thought we were supposed to get it was equal to the thing in the first row. Like, oh, we got y is equal to 1. Like, I thought it was supposed to be that number.
No, that's just another coincidence.
Okay.
That's not going to happen all the time. 1 times y is y, plus negative 1 times z, z is 2, equals negative 1. It's just that this particular example turns out that way, which kind of makes it not a good example, but that's the example we have to deal with that's on the study guide. Emily?
How did we get z equaling 2?
Because when we got it in a row echelon form, it gave us that. This is 1z, 1 times z, equals 2. Does that make sense?
Yeah.
Okay.
But
Go ahead.
we have another one on the top of z.
But it's not z, this is y.
No, on the
1
top of the
y.
z column.
Right, but there is other things, there are other things going on.
Oh, since there are 2 zeros there. that's
Right,
the only
exactly.
thing.
It's 0x, which is 0, plus 0y, which is 0, plus 1z, which is z,
Oh, it just
equals
clicked.
to, do you see it now? Okay, good. So now, the last thing to do is to write this, since we were given x, y, and z, is to write this as a point on a 3-dimensional coordinate system. And that's very, very simple. You put parentheses, you start with the x value, you then do the y value, you then do the z value. And that is the coordinates on a 3-dimensional graphing system.
Is that it?
That is it.
And stop?
Tomorrow, we will,
Stop this?
yeah, go ahead.